Hello, my name is Roy Simpson, and I'm a professor of mathematics at Cosumnes River College in Sacramento, California. In this lecture, we're going to go ahead and talk about matrices. Specifically, we're going to talk about definitions. We'll also just outline some reasoning behind the existence of matrices. It's not important enough for me to actually write that part down, but that's what we're going to go ahead and do. So let me go ahead and write down a few things here. For all intents and purposes, a matrix is just a rectangular array with, let's say, m rows and n columns that consist of numbers or functions. So you can kind of think of it as an Excel spreadsheet where you might have, let's say, 10 rows and 12 columns or something like that. And we often write a matrix in the following form, where we use a capital letter A. Often we use just any capital letter that we want. In this case, I'm choosing A because that tends to be the initial matrix that we're introduced to. A is equal to. And then you see that this matrix that I've written out, first of all, it's denoted with brackets, square brackets. It's traditional notation, although some people use parenthetical brackets. It has m rows. So let me go ahead and highlight so you can see. This is the first element of the first row, and here's the first element of the second row, and the first element of the third row, and so on and so forth, until you get down to the mth row here. And that mth row, so I'll just point an arrow and say that's the mth row, right? That would be the first element that I highlighted there in the mth row. And then if you count along the columns instead, you will see, and I'll use just a different color here for the columns. So this is the first element of the first column. Here's the first element of the second column. Here's the first element of the third column, all the way over here to where the nth element, the first element of the nth column. So let me go ahead and just point an arrow here and just say that's the nth column. And therefore, if you use the index notation that we are using, where the a sub ij is an element in that matrix, this is the element in the ith row and the jth column, as I've denoted here. And you may have, depending on the author of your text, they may have alternate notations for this matrix. So let's go ahead and just list out some notations you may see. So I've seen them. Oops, can drag that for a moment. I have seen these written as, for example, we'll just say that A is that matrix you've seen up there. So another notation for that would be A sub m by n, which tells the world that this is a matrix with m rows and n columns. It's a little more descriptive, I suppose. Some authors will even go so far as to use a notation like this. I'm not a big fan of this notation, but this you may see, A sub ij by sub m by n. That basically means it's a matrix and it's full of elements, ij elements, A sub 1, 3, A sub 3, 3, that type of thing, where there are m rows and n columns. Again, I think that's kind of not a sloppy notation, but not a very popular notation. And I think worse yet is this notation, A sub I j. This one, in many ways, is, I think, the most confusing of the group. The capital A or the capital A sub m by n at least tells somebody you're dealing with a matrix. It's very traditional to use capital letters for matrices. And not very traditional to use the parenthetical notation. So I will not be using the parenthetical notation. My notation will commonly be this notation here, one or the other. Now let's see, what other things can we define with matrices? Because right now what you're seeing is just this idea of what a matrix is. We have no idea what to do with it. Let's see, if you have a matrix that's just, let's say, a row. So let me go ahead and take out the pens here and say that I'm not even going to say sub anything. I'll just say A is equal to A sub 1, 1, A sub 1, 2, A sub 1, 3, all the way over to, let's pretend, A sub 1, n. That is a single row. That matrix only has a single row. It has n columns. We would call this a row matrix. And sometimes those are useful. Row matrices are useful. More often than not, though, actually a column matrix is more useful. And this time I'm going to use the alternate notation. I'll just use sorry, not 1 by, but an m by 1. That means it has m rows and 1 column. So that's A11, A21, A31, and so on and so forth, all the way down the line to AM1. That would be called a column matrix. Again, I think that this is much more useful in a field like linear algebra. Column matrices are much more useful there, in vector spaces as well. Now, because this video is only dedicated to definitions, initial definitions for matrices, I'm only going to mention one other definition here because, again, these are all very much the basics of matrices, just getting to know kind of what a matrix is. And so one last little definition here. If your matrix is n by n, in other words, it has as many columns as it has rows, then we would call it a square matrix. And actually, square matrices are very important in an analysis for, or in a course like linear algebra, and really are incredibly useful all throughout mathematics, honestly. So that is, I think, the last definition I'm going to have in this video. Yeah, I think that will do it. I just want to make sure.